Assalamu alaikum guys, how are you? I hope you are all well. Today's my topic of discussion is about potentials of the nerve cell. So there are three potentials of the nerve cell, which is a resting membrane potential, graded potential, and the action membrane potential. So resting membrane potential are the potential, all the voltage difference across the cell membrane, okay, at rest. Most important point is at rest, what are the voltage difference across the membrane of the nerve cell. So this is the definition of the resting membrane potential. And what are the resting membrane potential value? Minus what are the millivolts? So minus 70 to minus 90 millivolts are the resting membrane potential, and this potential is maintained by the three channels. For example, first channel is sodium potassium ATPases, second channel is sodium leaky channels, third channel is potassium leaky channels. So there is a lot of one important point in this channel is there is a lot of potassium channels, okay, lot of potassium channels which allow more negativity inside the nerve cell. Potassium channel are the most important, all of these, but mostly present potassium channel, but all of other channels are also important. So I'm gonna explain you the graded potential, which is after the resting membrane potential. Graded potential are the potential which is at the threshold, okay. So minus 70 to minus 90 is the range of the resting membrane potential, and minus 55, if I'm go more positive to the resting membrane potential, there is a threshold. So minus 55 is millivolts is the value of the threshold, is the graded potential. How it maintains, how it develops the graded potential? When sodium move inside the cell, when the sodium moves inside the cell, the potential goes up towards the positivity. So there is a positivity more inside the cell because of the sodium move inside the cell. So this is the mainly depends on the sodium, so it maintains the minus 55 millivolts inside the cell. So it's important for the action potential, because without threshold there is no action potential. So when there is a graded potential, is the potential of the nerve which goes minus 55. So after that there is a action membrane potential. So action membrane potential start after minus 55 millivolts. So minus 55 to plus 30 millivolts is the action potential voltage in millivolts, okay. So how it develops minus 55 to plus 30 millivolts? It depends, firstly it depends on the voltage gated sodium channels which is present on the axons, okay, axons of the nerve, voltage gated sodium channels which allow the sodium move inside very fastly and more, okay. So minus 55 to plus 55 is gone a lot of change of the potential. So due to the sodium channel which is present on the axon. Second one, there is a calcium channel. At the end of the sodium channel there is a plus 30 millivolt. The sodium channels become closed, and there is the activation of the calcium channel which is present at the end of the axon near the axon terminal, which basically allows the vesicles inside the axon to go to the membrane of the nerve cell and expel all the content inside the vesicle. So there is a neurotransmitter which pack inside the vesicles in the neurons. How? One question asked about you, how it moves out of the cell, okay. Vesicles, the content of the vesicle move out of the cell. It depends on the calcium channels which is present at the nerve terminal. Plus 30 millivolts allow the calcium channel to open and calcium channel move inside the cell for the vesicles, and vesicles move, calcium allow the vesicles to move at the cell membrane, and the cell membrane, and then it buds off, and then it expel from the cell, okay, nerve cell at the axon terminal in the synaptic cleft, okay. So plus 30 allows the vesicles to move its contents out of the cell. So plus 30 is the voltage. So this is the depolarization wave. So there is also a repolarization wave which followed the third channel, which is the sodium, which is the potassium channel, not sodium. Sodium is the previous one which helps the depolarization, and now the potassium channel. At plus 30 there is a potassium channel, allows the potassium to moves out. So plus 30 is the positive millivolts. So I am gonna resting membrane potential which again goes to minus -70 to -90. So potassium channels allow the potassium to move out, and potassium channel is positive charge, so move out of the cell. It means inside the cell there is more negativity. So due to the negativity inside the cell, so there is a plus 30 again goes to the -70 to -90 millivolts. Okay, so -70 to -90 millivolts, which allows the calcium channel inside the axon terminal to block. Okay, and there is no calcium inside and no vesicles more need outside the axon terminal, and there is a no need of more neurotransmitter which packed inside the vesicles. So guys, this is all about the action potential, resting membrane potential, and graded potential of the neurons. I hope you guys you enjoy this video, and you know you gain knowledge from this video. So guys, be happy, please like and subscribe, share my video, and support me. Thanks, goodbye.